Okay, boys, this is the chapter 3 review. We've got to do like just 1 through 12 is it for this. And that is all. So what I want you to do is, as you're watching this and going through this, pause, just kind of like we do sometimes in class where I'll give you a head start and then you can check your answer with me. Do that because that will be the best way to help you review for this test, okay? I am going to start, and instead of working back to front like we were doing before, I am going to work top to bottom or front to back, okay? Because we really need to do these log problems before we do these log problems, okay? Just to kind of as a refresher. So I'm gonna start at the top, and the very first thing that we started to do in chapter 3, like 3.1, was implicit, right? So before we were doing explicit functions where we had like y equals 3x squared, and we had to find the derivative, right? Okay, and the x's or y's are separated onto, you know, the y is on this side, the x's are all on this side, and that was easy, right? Y prime equals 6x, and we're done, right? But when we're doing implicit, the x's and y's are intermixed on the same side, so that's kind of a problem, right? So what we have to do is we start using and calling it, like y prime is what we can use, but we start using dy dx, right? And then this technically would be 6x dx, right? But dx dx goes away, so that's why we only have 6x on the right side, okay? So, and then when we get to related rates, which is what we've already done, we start taking the derivative with respect to time instead. So it's d whatever dt instead. So all of these up here, your designated variable that you're taking the derivative of is respect to x. That's why they say find dy dx. They're saying your specified variable, your special variable is x. So everything's in terms of x. So we're doing implicit here. All right, here we go. So pause this if you are ready for it. Otherwise, here you go. We have 3 pieces on this left side and 1 piece on the right side, but this one is going to involve the product rule. Okay, so I'm going to do this one first. This is 2x. You can put the dx on it if you want to, but you don't have to. 2x is that guy's derivative plus f prime g plus g prime f. All right, this is going to be my f part. This is going to be my g part. Okay, so f prime, the derivative of 3x is 3. Whoa, I got it. Okay, 3. And you can put dx if you want to, or you don't have to. Just g is going to be y. So the f prime g is going to be that guy. Plus g prime is the derivative of y, which is 1 dy dx, times f, which is 3x. So those are my pieces there, and that's my product rule. That is done. Plus the derivative of y cubed is 3y squared dy dx equals derivative of 10 is 0. Okay, now we've got a lot of stuff going on. I have 4 pieces over here. Really just 0 on the right side, so really kind of just have 4 pieces total, but I'm trying to solve for and get dy dx by itself. So if you remember from doing this a long time ago, we're going to keep these on the same side, and we're going to shove these over to this side, okay? So I'm going to do this. I'm going to say equals, if I shove those over to the other side, it'll be negative 2x minus 3y, okay? And then I'm going to kind of cheat also. These 2 pieces that are left over here, if I take the dy dx out in front, I am left with 3x plus 3y squared, right? Is that right? 3x plus 3y squared, I think. Okay, then to get dy dx by itself, I'm just going to divide him over. So dy dx will be negative 2x minus 3y all over this junk, 3x plus 3y squared. That's what my dy dx will be. Okay, so now that you've got those all kind of figured out-ish, I don't know why I have 2 2's. So this must be the real 2, and this is 3 maybe, whatever. I don't know, my numbering got all wonky. So there is that. All right, so let's try to do this too, okay? All right, this one, just as a preview, we're going to have a product rule here, but these guys are fine. So there you go. Pause now, do the thing, and then unpause. All right, here we go. X cubed is 3x squared. Dx dx if you want, but you don't have to. Plus 3y squared. This one will need dy dx. Okay, equals, this is going to be my f, this is going to be my g, and I have f prime g plus g prime f. I'm going to do my bubbles here so I don't forget anything. All right, f prime is the derivative of 3x, which is 3. G just stays y squared. G prime is 2y dy dx. F is 3x. Okay, I got a mess here. I'm gonna recopy. 3y squared plus this is 6xy dy dx. Okay, I'm going to, I don't know which side you move to. I'm going to move dy dx is over here, and I'm going to move this guy over here. Okay, so, and I'm going to do a lot of things at once. So I'm going to move this guy over here, and I'm going to pull my dy dx out front. So if I pull him out front, I have 3y squared over here minus 6xy. That's what I get if I move him over and pull that out. All right, equals, this guy's just chilling 3y squared, but now if I move that 3x squared over, he's minus 3x squared. Okay, and then I'm going to divide. So this is what he will look like. Last thing I can do is I can divide everything by 3 if I want to. Dy dx equals, I'm going to go y squared minus x squared over, yeah, y squared minus 2xy. That's what he will look like for the derivative. Okay, perfect. All right, I think these are all right. I don't know. I can make a mistake too, I guess. This one's probably the easiest one, honestly. This one has no product rule. He's just really easy. So, go, pause. Here we go. 2x plus 2y dy dx equals 0. I'm going to bump the 2x over. So 2y dy dx equals negative 2x. And if I divide the 2y over, I have dy dx. Oh gosh, my fraction bar is getting weird. If I divide by a negative, I've got negative x over y. That's what he will look like. Yeah, there you go. That's 3. Is that just 3? Oh my gosh. Okay. All right. Okay. The square root of y is y to the 1/2 power. Oh gosh, that's gross. Okay. All right. We got to do chain rule for that guy. So 1/2 comes down in front. Y to the negative 1/2, but don't forget he needs dy dx. So that's what he is. All right. The derivative of negative sine is negative cosine x equals 0. Okay, I can deal with that. All right. I'm going to fix this y to the negative 1/2 power. If I put him underneath with the 2, this is 1 over 2 square roots of y dy dx equals, I'm going to bump that cosine over, so he's going to be positive cosine x. Okay, and last thing, I want to get dy dx by itself, so I'm going to divide this over to the other side, or I'm going to multiply by 2 square roots of y, right? That's going to make him go away. So times 2 square roots of y. So if you want to, you don't have to. I'm going to put the 2 square roots of y in the front so it doesn't look like he is underneath of the cosine. Cosine x. There we go. That's what he looks like. You might have written him different and been okay. That's fine. All right. Good. Number 5, find the slope of the tangent line. That's just saying find the derivative of the graph of that thing at the point 10, 3. So I have to find the derivative, plug in that point. So I'm actually going to get a single number for the derivative, right? Derivative all along means slope of tangent line. Well, how can this be a slope, right? Isn't a slope a number? It is a slope. I just have to tell you what point to plug in. And in none of these up here, I told you what point to plug in. So that's why number 5 is a little bit more specific it's actually giving me find the derivative, find the slope, find the single number at this point, okay? So you have to find the derivative here, and this is implicit again because we have x's and y's together on the same side. But this one's not bad because no product rule, right? So 2y dy dx minus 1 plus 1 goes away equals 0 goes away, so I've got this going on. Well, that's kind of handy. If I add the 1 over here, this guy will be 1, right? 1 over on the side. And then if I divide by 2y, dy dx equals 1 over 2y. I don't know if that was hard to see, so I'm just solving this guy. Add the 1, divide by 2y. Okay, that is my derivative, but I want specifically at the point 10, 3. So dy dx is my derivative, and I plug in 10 and I plug in 3. But I only have a y to plug in for. That's fine. You plug in the 10. We're only going to plug the 3 in. So dy dx will be equal to, if I plug 3 in, 1/6. And that's all. Okay. When we were doing explicit derivatives, I forgot, I deleted my thing that I had up 3x squared, right? This would be like dy dx is equal to 6x. When we did explicit functions, you usually took this guy and you plugged it in, but you only used the x coordinate. Now, in this case, it just so happens that I only use the y coordinate when I'm plugging in to find the derivative. Whatever. So the slope of this tangent line will be 1/6. Now, in the next problem, in number 6, they're going to say find the equation of the tangent line. So if I was doing that here, this would be 1/6 x plus b, and I'd have to solve for b by plugging these guys in, right? 10 and 3, okay? So they didn't ask me to do that on number 5, but I'm going to do that here. Find the equation of the tangent line. So I need all of the y equals mx plus b to find the equation of the tangent line. All right, so this guy is my original. I'm going to do the derivative. Don't forget dy dx on your y's. Oh, dx equals 0. Okay, I'm going to bump this over. So 2y dy dx. And if you want to skip steps, you can. Divide by 2y. So dy dx is equal to negative x over y. If I divide the 2 by 2. Then I need to find my slope. Okay, so that's my derivative. But that's not a specific derivative. I need to plug my point in. So I'm going to plug in 3 in the top, 1 in the bottom. Hey, that's a nice slope of negative 3. Perfect. So now I am at the point where I have y equals negative 3x plus b. And I need to solve for b. So I'm going to plug 3 in for x and 1 in for y. This is negative 9, so I'm going to add the 9. And b is 10. And I'm not going to circle that. Final answer for the equation of the tangent line is y equals negative 3x plus 10. Okay, just so you know what we're doing right here. This is actually the equation of a circle. X squared plus y squared. He's a circle centered at 0, 0 with a radius of square root of 10, which is like a little over 3 for a radius, right? Don't draw this. Don't draw this. Centered at 0, 0, radius of a little over 3. Oh, gosh. So something like this-ish. I don't know. Whatever. Something like that, right? And at 3, 1, he's touching right here. This is his tangent line, right? He's going to y-intercept up here at 10, and his slope is going to be negative 3. Whatever. That's what we're doing. Okay? So that's just what you found. All right, we've got a couple left. These are going to go fast. So I'm trying to find derivatives of ln's, and when you're doing derivative of ln, it is 1 over the original times the derivative of it, which is 3x squared plus 2, but we just go and lump him on the top. Okay, so 3x squared plus 2 over x cubed plus 2x minus 7. That's what he will look like for his derivative. Very fast for ln's. I like ln's. Okay, this one, number 8, I'll give you a little hint. I'm going to put this 1/2 here, but then I'm going to move the 1/2 down in front. So I am finding the derivative of 1/2 ln x. Okay, All right, so pause if you think you can. Here we go. 1/2, we don't have to use the product rule, right? Even though there's like two pieces here because the 1/2 is a constant, okay? So the 1/2 is just chilling, but the derivative of ln of x is 1 over x, right? Right, 1 over the original, right? Times the derivative of the inside, which is just 1. The derivative of x is just 1, so I don't really need that. So this is 1 over 2x is the derivative of that thing, okay? So the very wonderful thing about ln's is the exponents can come down in front and all that good stuff, okay? Very wonderful tool. I'm going to go down to number 10 first because I had to go look back and write this rule down. This is the rule that you're going to use for finding log of this thing, all right? So we have log base b of u. What is b? B is 4. U is 3x. So when I'm plugging this in for my derivative, it is 1 over u, which is 3x, times ln of b, which is ln of 4. And then du dx is the derivative of u, right? Derivative of u. And u is 3x. So I want to find the derivative of 3x, which is just 3. And the only other thing I'm going to do is I'm going to lump him on top. So, oh, and actually, I could, since this is all one piece on the bottom, I could cancel my 3's, right? Because one's on the top, one's on the bottom. That's kind of fancy. So 1 over x ln 4. There we go. That'll work. Okay, fancy. All right, I'm going to use that same rule over here to do this guy. I don't know if I have room. Let's just bring him with me. Sure, there we go. Look at that. All right. I'm going to get rid of some of this, though. So fancy. Oh, I got rid of a line. All right, there we go. Okay. All right, so this is another log, and the log, the base of the log is 10 because there's no number. All right, so here we go. B is 10, u is x squared plus 3, so I'm just going to follow the rule. All right, 1 over u, and u is x squared plus 3, times ln of b, which is ln of 10, times du dx, which is the derivative of this guy, which is 2x. And I'm going to lump him on top. And that's all. 2x over x squared plus 3 times ln 10. That is all. Don't forget to put parentheses around him. He needs them. But that's it. Okay, not so bad. I don't really care for the log ones. I much prefer ln, but whatever. It's fine. Okay, all right, last two. Use log differentiation to find the derivative of each, okay? If I didn't use logs, I would have to resort to using the product rule, but then within the product rule, this would be a chain. So it's like a chain inside of a product, and that would be lots more unpleasant. So what I'm going to do is I'm going to ln both sides. And when I ln both sides, I can tear this apart, okay? So this side's going to chill as ln y. But then multiply means add, so I'm going to break them apart. Ln x plus ln of the square root of that, 1 plus x squared. But the square root just means to the 1/2 power, and then the 1/2 can come down front. So 1/2 here. All right. The derivative of ln of y, I'm going to start right here. The derivative of ln of y is 1 over y, but I need to do y dx. Equals the derivative of ln of x is 1 over x, right? dx, but I don't need that, right? Plus the 1/2 is just chilling. Then I need to find the derivative of just this part, or ln of that part, I guess I should say, which is 1 over 1 plus x squared times the derivative on the outside. So I'm just going to lump him on the top. So 2x. Okay. And then 1/2 and 2, this guy will cancel, right? So I just have x over that thing. And then if I'm finding dy dx, this stuff is 1 over x, plus x over 1 plus x squared. That's what this stuff is right here. Okay, but then I need to multiply the y over. So y goes in this spot, except y is this junk. X square root of 1 plus x squared times that junk. That's a big, ugly thing. But every time I say that, I say that's a big, ugly thing. But it would be even worse if we have to do a product or a chain inside of a product and like that ugly stuff. Gross. Okay, so that was 11. All right, 12, similar. Okay, this would be a quotient, right? Quotient inside of a chain, right? I don't want to do that. So I'm going to ln both sides. Ln, ln. All right, now, the tricky part to this is that if I break those apart, that's fine. But this would be like ln of x minus 1 minus ln of x plus 1. But since all of that is underneath of the square root, the 1/2 power gets applied to each one of them. So it's like this is to the 1/2 power, this is to the 1/2 power, right? Because they're both underneath. And then that 1/2 comes down in front. So I'm going to do that now. And now I'm going to find my derivative stuff, okay? So derivative of ln of y is 1 over y, dy dx, equals, this 1/2 is just chilling. Derivative of that is x minus 1 times the derivative of x minus 1, which is just 1. So I'm going to lump him on the top. And then I've got minus 1/2 just chilling again. Derivative of, just x plus 1 goes on the bottom. The derivative of x plus 1 is 1. That goes on the top. So let's see. How do we want to simplify him? Dy dx equals, I'll save space for that y. I'm going to put this together. So this is 1 over 2x minus 2 minus 1 over 2x plus 2. And then he is times y, because I got to multiply this y to the other side, right? And y is the square root of x minus 1 over x plus 1. That's what y is. And that's it. Kind of ugly, but better than doing a quotient inside of a chain. All right, that was a lot of stuff. That took a little bit more time than I thought it was going to. Sorry about that. Okay, that's all for today. And have a good weekend.